Welcome, my dear students. Myself, Dr. A. Venkatesan, Assistant Professor, PG and Research, Department of Mathematics, St. Joseph College of Arts and Science, Autonomous Cuddalore. In this video, we're going to learn Haley-Hamilton theorem from Allied Mathematics. What is Haley-Hamilton theorem? Every square matrix satisfies its own characteristic equation. What is square matrix? A matrix with the number of rows equal to the number of columns. That is, orders are same. For example, a matrix of order 3 cross 3, a matrix of order 4 cross 4, or any matrix with n cross n. Some applications. Computing matrix functions. The theorem can simplify the calculations involving powers of matrix, like to find a inverse or exponential of matrices. System stability. In control theory, the Haley-Hamilton theorem used to analyze the stability of systems, eigenvalues and eigenvector. It provides the relationship between the matrix and the its eigenvalues. Now we're going to find a inverse of the following 3 cross 3 matrix. To find an inverse using Haley-Hamilton theorem. So to find inverse, before that to find a characteristic equation. So for that, first I find S1. What is S1? Sum of the diagonal number. What are the diagonal numbers here? 1, 1, negative 3. So now we add 1 plus 1, negative 3, you can get negative 1. Now we find S2. What is S2? S2 is the minor matrix with respect to the diagonal numbers. The minor matrix of the diagonal numbers. So first I find the minor matrix of the first diagonal number. So we get 1, 3, 2, negative 3. Similarly, for the second number, you get 1, 2, 3, negative 3. For third number, you get 1, negative 1, negative 2, 1. So now we expand the matrix as per the determinant A, B, C, D or the determinant. You expand AD minus BC. So you get negative 3 minus negative 6 plus negative 3 minus negative 6 plus 1 negative 2. So you get negative 9, negative 9, negative 1. So answer is negative 19. Next, you find S3. So the S3 is represents the determinant of A. So you will not get how to find the determinant of A for the row wise. So therefore we get the first number 1. The first row, the first column, we eliminate. So once again you can get minus 3 and minus 6. Then sign will be changed. So therefore negative into negative positive. So the positive 1 of you get the value as we remove from this matrix first row and the second column. So you get negative 2, 3 and 3, negative 3. So the values are 6 minus 9. And the third one 2. That is you remove here the first row and the third column. You can get negative 2, 1, 3, 2. Get the value is negative 4, negative 3. So therefore, we get negative 9 and negative 3 and negative 4, 14. So therefore, possibly you add this value. So you can get negative 26. So you get S3. So now we find the characteristic, write the characteristic equation. So the characteristic equation we can write is the lambda q minus S1 lambda square plus S2 lambda minus S3 equal to 0. Already you know S1 equal to the value is -1 and S2 equal to -19 and S3 equal to -26. Now we substitute here. So you can get lambda q. Already you have a minus. So negative into negative positive. So therefore lambda square. Positive into negative negative. So therefore -19. Once again negative into negative positive. So therefore we can get 26 equal to 0. So this is the characteristic equation. So now we verify this satisfies the equation with word matrix. So for that, I replace this lambda by a. So I write a cube plus a square and 19a plus 26I equal to 0. But here our problem is to find A inverse. So therefore, we multiply by A inverse on both sides. So we multiply A inverse on both sides. So we get A square plus A 19I plus 26 A inverse equal to 0. So from this we write A inverse equal to 1 over 26 of 19I minus A square and minus A. So now we find what is A square and what is 19I and simplify, you can get the A inverse. So you know the A value and we find A square. How to find A square? A times A. So you know the A value 1, -1, 2, -2, 1, 3, 3, 2, -3. Similarly, you get another one times you write 1, -1, 2, -2, 1, 3, 3, 2, -3. So now we multiply by matrix multiplication. So if you multiply this one, you can get the first row with the first column. So therefore you can get 1 plus 2 plus 6 first row number. Then first row, second column, you write. We get -1, -1 plus 4. Then first row, third column, you write 2 minus 3 and -6 for the first. Similarly, now we vary with row wise. Second row, first column, and second row, second column, and second row, third column. So we get -2, -2, plus 9, 2, plus 1, 6, -4, plus 3, -9, and 3, -4, -9, -3, plus 2, -6, 6, plus 6, plus 9. So now we add the value. You can get 9, 2, -7, 5, 9, -10, -10, -7, 21. So you get A square. So now we substitute the value of A inverse. So what is A inverse? A inverse is equal to 1 over 26 of A square, 19i minus A square minus A. If you write the 19i is 19, 0, 0, 0, 19, 0, 0, 0, 19 minus A square value we find previously 9, 2 minus 7, 5, 9 minus 10, minus 10, minus 7, 21, minus A value 1, minus 1, 2, and minus 2, 1, 3, 3, 2, minus 3. If you simplify, you can simplify. So therefore 1 over 26 of the first one. 19 minus 9 minus 1, you can get 9. Minus 2 plus 1, you can get minus 1. Plus 7 minus 2, you can get 5. Minus 5 plus 2, you can get minus 3. 19 minus 9 minus 1, once again you can get 9. Minus into minus plus, so plus 10 minus 3, you can get 7. 10 minus 3, 7, plus 7 plus 2, plus 7 minus 2, you can get 5. 19 minus 21 plus 3, so 1. So therefore the A inverse for the matrix of order 3 cross 3 is 1 over 26 of 9 minus 1, 5. The second row minus 3, 9, 7. Third row 7, 5, 1. So using Haley-Hamilton theorem, also you can find A inverse. Thank you.